Hello children, in this video let us learn exercise 13.3 question number 8. Up to 7 we have done in previous video. I hope these videos are helpful for you in learning. Let us see question number 8 of this exercise. The question is water in a canal 6 meter wide and 1.5 meter deep. So, this is the dimension of canal. We go with this dimension. For a canal, width is, wide it is given. So, we will use here width, that is 6 meter, and deep we will use depth, that is height of the canal 1.5 meter. So, these two dimensions width and height are given for canal. Then water is flowing in the canal with the speed of 10 km per hour. So, this is the condition we need to understand here. The water in the canal is flowing with a speed of 10 km per hour. Speed of 10 km per hour. So, what do we mean by this speed? The unit of speed is kilometer per hour or meter per minute or meter per second. Here we have unit kilometer per hour, and what we see dimension of canal both are in meter. So, first we need to convert it into same unit already. The thing is that this is not just 10 km, it is 10 km per hour. That means, in 1 hour the water move from one point to another, that distance is 10 km. So, we will calculate speed of water per minute. How to convert it? Meter to be converted into kilometer to be converted into meter, that is 10 km, and there are 1000 meter in 1 kilometer. So, 10 into 1000, surely 10 km equal to 10,000 meter. This is in how many minutes? It is given here in 1 hour, but I am asking you here this 10,000 meter in how many minutes? So, surely you will say per hour, that means in 60 minutes. So, the water is flowing 10,000 meter in 16 minutes. If we divide the distance by time, we will get speed. In physics also you are studying time is equal to distance by speed, speed is equal to distance by time, and all those things. So, now this unit is meter per minute. We can simplify 0, 2 3s are 2 5s are, sorry, 2 5s are 10, 2 3s are 6. So, we finally what we get 500 by 3 meter per minute. Now, let us understand something more. The water is in the canal from here to here, it is flowing, that is 500 by 3 meter in 1 minute. That means, every minute the water is covering this distance, that means that is the length of water in 1 minute in the canal. Once more, in 1 minute the length of water in the canal is 500 by 3 meter, and width and depth, that is 6 and 1.5. So, what is the amount of water every minute flowing in the canal? We can calculate it, the volume of water or amount of water. Volume of water in the canal in 1 minute, mean every minute how much water is flowing through the canal, that will be length into breadth into height. Length and breadth are there, width and depth are there, and length distance, that is the length of water in the canal. So, length 500 by 3, width 6, and depth 1.5. We can simplify it here, 3 1s are 3 5s are 15, 0 0 cancel. So, every minute 50 into 6 into 5, that means 5 5 6 are 35s are 150 and 1 more 0. So, 1500 meter cube of water every minute, cubic meter, it is volume actually, it can be converted into liters also, but that is not asked in liter, how many liter. The next part of the question is an area, that means a piece of land is irrigated in 30 minutes. but we need 8 centimeter standing water on that land irrigated area. how much area we are irrigating, 30 minutes we are supplying water in that, and we need 8 centimeter of standing water on that area. So, let us see, in 1 minute 1500 meter cube. So, in 30 minutes how much water? Therefore, in 30 minutes the volume of water will be 30 into 1500 meter cube. So, this will be the total amount of water is in the field on particular area, but we need what? 8 centimeter of standing water is needed on that area. 8 centimeter of standing water is needed on that area, is needed on the irrigated area, we can say. Irrigated area. Again, one small problem is here, what? All other unit we have converted in meter, but this height of water is in centimeter. So, we will not proceed without converting it into meter. We will work with the same unit. So, that standing water is height of the water on that area. 8 centimeter, convert it into meter. We will divide it in meter, because 1 meter equal to 100 centimeter. Now, everything is okay. All the units are same. We understood that particular land we are going to irrigate. We are supplying for 30 minutes. This much water will be in on that area, and water is standing for 8 by 100 meter. So, now we will go. Question is asked here, how much area is irrigated? So, the volume of water on the irrigated area. Water on the irrigated area, how much water we have supplied in 30 minutes? 30 into 1500. So, this water is there in the field. Question is asked, what area we have irrigated? So, the particular land will have length and breadth, and standing water is the height. So, we will use here the formula length into breadth into height only. It will take the shape of a cuboid, and that is 30 into 1500. Length and breadth together gives us area, you know that, and height 8 by 100. So, length and breadth we keep here, and height we use 8 by 100, that is 30 into 1500, and rest is only simplification. 8 by 100 we take in RHS, length into breadth we will get area. So, length into breadth is equal to 30 into 1500, and 8 by 100 comes in RHS, it will become 100 by 8. We will cut 4 2s are 8, 4 25s are 100. By 2 also it is possible to cut, 4 15s are 2 1s are 2 15s are 30. So, what we get finally? Length into breadth is equal to 15 into 15, 225, 225 into 25. 225 into 25, 5, 25, 10 to 12, 11, again 450. We get 5, 2, 6, 5. So, 5, 6, 2, 5. We have multiplied this number 15 into 15 into 25, and still 2 zeros are there. We will put these 2 zeros. What is this? Length into breadth. If you are asked length into breadth, surely you will say area of rectangle. So, that part of length is rectangular, that is why length into breadth is that. So, automatically we can say the irrigated area this is rough work, is equal to 5,62,500 meter square. We will write it meter square, because area you know represented in square unit we have used meter only. So, finally, we reached this area will be irrigated in 30 minutes if 8 centimeter standing water is needed on the field. So, let us summarize this problem. What we did, the canal dimension is there, width and depth, then speed of water is there, per minute we converted it, then in 30 minutes how much what amount of water is there on that particular irrigated area, and then we use the formula again and calculate it when we found. I hope you have understood. Now, in next video we will start the last exercise of your surface area and volume, that is 13.4. Let us read now question number 9. The question is here: a farmer connects a pipe of internal diameter 20 centimeter from a canal into a cylindrical tank in her field, which is 10 meter in diameter and 2 meter deep. If water flows through the canal, through the pipe at the rate of 3 km per hour, in how much time will the tank be filled? So, interesting situation here. Sometime we do this kind of work, maybe at our home or in the field or wherever. What is that? A pipe of internal diameter. So, let us go for a pipe. We know what is the shape of a pipe. So, for a pipe, internal diameter, that is 20 centimeter. Internal diameter, remember diameter is this, how much? 20 centimeter. Then it is, the pipe is connected from the canal into a cylindrical tank, which is 10 meter in diameter and 2 meter deep. So, another one is for a cylindrical tank. What we have? We have 10 meter diameter and depth is deep, or we just write depth. Depth of the tank is the height of the tank, you know, 2 meters. And then the water is flowing through the pipe at the rate of 3 km per hour. That situation also we will write here. The water is flowing through the pipe or flows through the pipe at the rate of 3 km per hour. So, how much time it will take to fill the tank? Let us go, internal diameter of the pipe is there 20 centimeter, other dimensions are in meter, we see somewhere kilometer. Anyway, we will decide first of all the same unit we need to convert. So, centimeter, meter, kilometer. So, let us divide all that into meter. So, 20 centimeter we can convert 20 by 100, this will be now meter, but it is diameter. So, we need therefore radius of the pipe, that will be half of diameter, that means divide by 2. So, in denominator we will write 2. Okay. So, 2 ones are 2 tens are, again 0 0 cancel. What is the radius of pipe? That is 1 by 10 meter. We can convert into decimal also, but no need, just leave it in this form. We find now that cylindrical tank, pipe is connected, suppose canal, no need diagram and all, pipe is connected, it is cylindrical pipe, and then this is cylindrical tank. This is the situation here. In this pipe, water is flowing with the speed of 3 km per hour. So, how much time it will take to fill this tank? Situation is this, I hope it has come to your imagination. Okay. So, we have diameter, so we need radius. So, radius will be how much? Half of that 10 by 2, that means 5. What is the unit? 5 meter. This also okay. Depth is the height, you know, you can write here in bracket just to remind yourself, this is the height, 2 meter. Now, we come like last question number 8, water was flowing in the canal 10 km per hour or whatever may be the speed of water. The thing is that 3 km per hour, that means in 60 minutes water is flowing 3 kilometer. That means in 60 minutes water is flowing for 3000 meter. So in 1 minute how much it will? So let us start. So the water flows through the pipe at the rate of 3 kilometer per hour. Therefore, speed of water per minute in the pipe, speed of water, just we can write per minute. It is mentioned here water is flowing through the pipe only. So speed of water per minute. So what shall we do? Kilometer we will convert into meter, hour we will convert into minute. Is it clear? So once more, in 60 minutes 3000 meters. So in 1 minute 3000 divided by 60. So 3 into 1000, it will become now meter, 3000 meters in 60 minutes, and we are calculating for per minute in 1 minute. So divide by 60, 0 0 cancel, 3 1s are 3 2s are 2 1s are 2 5s are 0. That means water is flowing through the pipe per minute 50 meters. In 1 minute 50 meter water is flowing. All right. Now the question is what? How much time this pipe will take to fill this tank? So let us first of all we will find out in 1 minute what amount of water is falling in the tank. Then what is the capacity of the tank? Capacity of the tank divide by the amount of water falling in the tank in 1 minute. Did you understand? What shall we do now? We will go for per minute how much water is flowing or falling in the tank in 1 minute. So volume of pipe, volume of water per minute in the pipe. Pipe is cylindrical, we will use cylindrical formula. Then what is the capacity of that tank, cylindrical tank? And then cylindrical tank volume divide by the per minute water falling in the tank, we will get the time. Let us do that part. So I will clean this diagram, is not needed here, everything is in our imagination, we can imagine this simple situation and then start. What we are going to calculate first? Volume of water in the pipe per minute or in 1 minute, same meaning it is. What is the shape of pipe? Cylindrical. So we will use pi r square h. Pi 22 by 7, radius r square 1 by 10 into 1 by 10, and every minute how much water is flowing in the pipe? That is the speed of water per minute. So length of the pipe, length of the water in the pipe is the height. So that is 50. So every minute this much water is flowing through the pipe and falling into the tank. Situation is same only. Pipe is in pipe water is flowing and falling in the tank only. So now we will go for capacity of the tank and the volume of tank. You know volume or capacity, volume of the cylindrical tank. So here also shape is cylindrical, we will use cylindrical formula only. Volume pi is 22 by 7, radius of the tank how much? That is 5. So 5 into 5, and height of the tank is 2 meter cube. So this much water will fall and fill this amount, this capacity of tank. So how many minute water will flow? So and here we can find the time required to fill the tank is equal to volume of the cylindrical tank by volume of water falling into it or flowing in the pipe. Volume of water in the pipe per minute. Both we have, we will just calculate. Volume of cylindrical tank 22 by 7 into 5 into 5 into 2, volume of water 22 by 7 per minute, how much it is flowing? 1 by 10 into 1 by 10 into 50, 22 by 7 gone. Now, here if you feel any doubt, little wait, let's see first what we do. What is easily possible to cut, we will cut. 5 ones are 5, 10s are 50. 5 ones are 5 twos are 2 ones are 2 ones are. So, numerator what we see? Numerator is 1, nothing is remain here, everything is cut. And denominator what we find now? 1 by 10 remains. So, what 1 will remain here and 10 will go in numerator. This 1 will remain in denominator and 10 will go in 1 will remain in denominator, 10 will go in numerator. Finally, we get 100, 10 into 10. That means, in 100 minutes the tank will be filled if the water in the pipe with this dimension is flowing at the at the speed of 3 km per hour. Once more, just summarize the whole solution. What we did in that? We found first of all diameter was there, different units were there, we converted all the units into same unit meter. Then we calculated in 1 minute how much water is flowing through the pipe. Then separately we found the volume of tank and volume of pipe, and then volume of tank divided by volume of water in the pipe per minute and calculated, we found very easily. So, now we are reaching the last exercise of surface area and volume. I hope you are learning this all properly. Let us see in the next video, we will start the last exercise 13.4. See you in next video.